As we talked about the changes that occur in the embryo during the third week, it ends up with gastrulation, which is the process which converts the bilaminar germ disc into trilaminar germ disc by the formation of the primitive streak that appears on the caudal end of the dorsal surface of the epiblast. This is a primitive streak through which the stem cells of the epiblast will migrate through it and enters the site between the epiblast and hypoblast, and these cells will migrate. Some of them go laterally, some of them go cranially, forming the third germ layer, which is the mesoderm. This is the intraembryonic mesoderm, and it will be connected with the outer or extraembryonic mesoderm. Some of these cells will displace the hypoblast cells, forming the endoderm. The rest will form the mesoderm. So the gastrulation ends up with 3 cell layers. Each one of these cell layers will give rise to many derivatives. Here again, this is the primitive streak composed of this is the groove, primitive node, and knit, and this is the primitive pit. Here you can see the migration of cells from the epiblast, which are adjacent to the primitive streak. They enter this area, forming the third layer. So this structure ends up with the 3 cell layers: the epiblast, which is named now the ectoderm, the mesoderm, and the endoderm. This slide shows the directions of the migration of the cells that migrate from the epiblast through the groove of the primitive streak. They go in different directions. Some of them go laterally, some of them go cranially toward the head region of the embryo. After gastrulation, the further development of the embryo occurs by formation of a structure known as the notochord process. The notochord process appearing at this stage when the mesenchymal cells migrate from the primitive node to form a midline cellular cord, which is the notochord process. Here is the notochord process, and this is a primitive node. Here the cellular cord appears, which forms the notochord. It grows cranially toward the head region until it reaches the precordial plate. This precordial plate represents the future mouth. And the notochord, when it is formed, it forms the first longitudinal midline axis of the developing embryo, around which the vertebral bodies will be organized as the basis of the axial skeleton. Here again, as I mentioned before, the mesenchymal cells, they migrate cranially from the primitive pit. This is a primitive pit and the primitive node, and this is the site where the notochord appears. This cord will be canalized, forming a hollow tube, or it's named the notochordal canal. Neurulation, it's a process that refers to the folding process in the vertebrate embryo. This includes transformation of the neural plate into neural tube, where the embryo at this stage is termed neurula. This is the notochord. It starts giving signals to the overlying ectoderm. Here, this area, exactly, it will be thickened, forming the neural plate. This is the neural plate. Later on, this plate will be elevated at the borders, forming the neural folds. These are the neural folds. It will continue to elevate until they form. This is the groove, forming the neural groove, and these are the edges of this plate. They will meet together at the midline, forming the neural tube. It was a plate, and then due to folding at the edges, it will form the tube. This is the neural tube. Formation of a dorsal hollow neural tube by the ectodermal cells. They flatten into neural plate. Later on, the center of the plate sinks, forming the neural groove. Edge of the plate, as I mentioned before, will be elevated to form the neural folds. These folds fuse at the midline, forming the neural tube. As you can see here, this is the ectoderm. This part, which is named the neural plate, is thickened due to the signaling that occurs or sent by the underlying notochord process here. It will give signals to this area, forming this plate, and these edges of the plate will be elevated, forming the neural groove. Then these two edges meet at the midline, fuse together, forming the neural tube. So this plate will change into a closed tube, which is the neural tube. Here again, this is the notochord. This part of the ectoderm will be thickened. And you can see here, these edges are elevated, and these two edges will be close together until they meet, forming the neural tube. The notochord is still apparent here. Then the structure, or the neural crest cells, as you can see here, they appear at the edges of this plate. These will later on, after closure of the tube, these cells will detach from this area and will take their pathway in their migration, and they will give certain structures of the embryo. Here again, you can see this is scan electron microscope view of the plate. And here the neural groove. This is the plate. This is the groove formed due to the elevation of the edges of this plate, forming the groove. Later on, these edges meet together, forming the neural tube, as you can see. And this is the notochord. This is the tube closed, and this is underlined by the notochord. Now, the neural crest cells. These are very important structures. They contribute to so many organs and tissues that are sometimes referred to as fourth germ layer. It's considered as a fourth germ layer. We have mentioned there are 3 germ layers, which are the ectoderm, mesoderm, and endoderm. Some consider the neural crest cells as the fourth germ layer. They give rise to certain structures as for the dorsal root ganglia, Schwann cells, autonomic nervous system, meninges, and sensory ganglia, bones of the face, teeth, nails of the eyes, melanocytes, and adrenal medulla, and many glands. Here is the site of the neural crest cells at the periphery of the neural plate. They appear here at the crest of this elevated edges of this plate. Later on, after a closure of this tube, as you can see here are the cells. They are detached from this area, and they go take their different directions in their migratory pathway. Here, this is the site of the neural crest cells at the edge of this folding neural plate. This is the notochord, ectoderm, mesoderm, and the endoderm. This is the site of the intraembryonic mesoderm, which is connected with the extraembryonic mesoderm. Here again, this is the neural tube. It's closed except for the cranial region and the caudal region. This is called the cranial neuropore, and this is the caudal neuropore. They are still non-fused at these both regions. This is the anterior neuropore or the cranial neuropore, and this is the caudal neuropore. This figure shows the direction of closure of this neural tube. The cranial neuropore closed first, and then followed by the closure of the caudal neuropore. Sometimes any defect during closure of both pores will cause deformities or congenital anomalies in the developing embryo at the caudal region or at the cranial region. Thank you.